Sunday, September 9th, 1900, revealed one of the most horrible sights that ever a civilized people looked upon. Where 20,000 people lived on the 8th, not a house remained on the 9th. About 3,000 homes had been completely swept out of existence, and probably more than 6,000 persons had passed from life to death during that dreadful night. Isaac Klein, U.S. Weather Bureau, Galveston, Texas.
The largest loss of life in any hurricane in the United States was the Great Galveston Hurricane in 1900. And the forecaster in charge of the Galveston office at the time, a man by the name of Isaac Klein, had no tools, had no satellite. You know, he was really blind back in those days.
Still in its infancy in 1900, the science of forecasting evolved in the ensuing decades. Technologies emerged to improve observations and predictions. By mid-century, weather forecasting had improved. But to get the big picture, we needed a more omniscient observer. First, radar was adapted in the 1950s as a means to see local precipitation. Then, in 1960, TIROS-1, the first weather satellite, was launched. Orbiting from pole to pole, early weather satellites were like a police officer on the beat, glimpsing clouds at every point on Earth twice a day. But severe weather changes fast, demanding a more persistent set of eyes in the sky. A satellite 23,000 miles over the equator would have an orbit that matches the Earth's rotation exactly. Such a geostationary satellite would be like a guard in a watchtower, spying clouds as they develop and keeping forecasters one step ahead of the storm. Early experimental satellites proved this concept, and the first geostationary operational environmental satellite, NOAA's GOES-1, was launched in 1975. Since the advent of weather satellites, loss of life from storm surge has plummeted, and 4 generations of GOES have kept the promise that no hurricane would surprise Galveston or any other city ever again.
Today, especially with the geostationary satellites, there's no reason to be surprised. We're still going to have hurricanes, we're still going to have some loss of life, but there's not going to be a total surprise because people can see the threat as it approaches the coast. People say a picture's worth 1,000 words. When people in Louisiana saw that satellite image of Hurricane Katrina, that certainly got their attention.
You know, satellite imaging is critically important. It's important to us. It's important for the information that's provided to us by the National Hurricane Center, and then our partners in the media, the way they present the information to the public, it's also very, very crucial.
Continuity of GOES observations is now essential for community preparedness. As historic storms of the new millennium prove, there is no end to the threat of deadly weather.
I think trying to operate and try to make some of the decisions we need to make without the geostationary satellites being available to us would be near impossible. Trying to make decisions for a county that's 2,000 square miles, 2.5 million people, I just couldn't imagine what we would have to do to be able to operate in that kind of a capacity.
NOAA's newest satellite, GOES-R, offers the critical continuity of life-saving weather observations. GOES-R will fly an advanced set of sensors. These new Watchful eyes will monitor the atmosphere, the ocean surface, and even the sun in more detail and more often than ever before. At the heart of GOES-R is the Advanced Baseline Imager, or ABI.
ABI gives us tremendous capability. It is the keystone of the GOES-R satellite. ABI will allow us to see the continental United States more often. It'll be able to see things in much more detail. It'll be able to see things sooner.
The Advanced Baseline Imager will image 6 times faster than its predecessors, seeing the entire hemisphere every 5 minutes, and will reveal twice the detail in cloud features.
It's going to save lives. It's going to save thousands, if not millions of dollars.
Well, they're not just used for hurricanes. I mean, they're used for all types of weather, severe thunderstorms, tornado outbreaks, winter storms, flood events.
Preventing loss of life with earlier tornado warnings remains a challenge. Here, the first ever geostationary lightning mapper, or GLM, may make a big difference.
GLM could double the lead time, the warning time, for an impending tornado.
Rapid increases of lightning inside clouds can distinguish a routine thundershower from a deadly tornado producer. GLM will watch for this severe weather indicator on a second-by-second basis to inform NOAA forecasters. GOES-R will also monitor the sun with a new solar ultraviolet imager, or SUVI.
The sun is the source of all of our weather, and as such, we have a solar ultraviolet imager that watches the sun continuously.
Solar storms can cause electrical power grid problems here on Earth and can threaten space travel for astronauts and disrupt communications. More than a triumph of technology, GOES-R will provide a window to our planet that will fill us with awe and occasionally alarm. GOES-R will draw a bead on future Katrinas and Sandys long before they threaten our coast. And, for a generation to come, the daily march of other threatening weather will not escape NOAA's new, watchful eyes in space.
There's no doubt in my mind that the geostationary satellite has helped save lives.
Geostationary satellites absolutely save lives.
When severe weather is coming, GOES-R will help communities prepare for the worst.